All right, right now we're going to be working on operations with radicals. This is very similar to combining like terms with variables, but now instead of variables, we're going to have radicals. So for our first example, we are going to be adding 5 root 7 plus root 11 minus 8 root 7. So we can see that there's a 5 root 7 and an 8 root 7. So because both of these radicals have a root 7, we are allowed to combine them together. So I'm going to use the commutative property of addition just to reorder them. So we have 5 root 7 minus 8 root 7. We're going to combine those. And then we have root 11. So when we're combining like terms with like x squared or x cubed plus x cubed, remember we don't do anything with the exponents. Like we don't add the exponents, so an x cubed plus an x cubed would be 2x cubed, not x to the 6th. So all we're going to do is add the coefficients. So we're going to have 5 minus 8, or really 5 plus negative 8, root 7 plus root 11. So 5 minus 8 is negative 3. Root 7 plus root 11. This is your final answer. Okay, let's look at another one. So for our second example, we have 10 root 5 plus root 20. So immediately you notice that there are no common radicals, so we want to try and make them match. So the square root of 5 is already in its most simplest form for the 10 root 5. So we're going to try to simplify the 20. And we can simplify that 20 into 4 times 5. So that would be the square root of 4 times the square root of 5, which is 2 root 5. So now we have 10 root 5 plus 2 root 5. So all we have to do is add the 10 and the 2. They both have a root 5, so 10 plus 2 is 12 root 5 for your final answer. Let's try another one. So your next one's going to be 2 root 6 minus 5 root 54. So I know 54 is going to be made up of a 9 times a 6, and that way I have a root 6 and a root 6. So let's work on simplifying this root 54. So we know it's 9 times 6. Okay, so we have the square root of 9 is 3, so we're going to have 5 times root 9 times root 6. Root 9 is 3, so we have 5 times 3 times root 6. That will give me 15 root 6. So now we're just going to bring down the 2 root 6 that didn't need to be simplified, and then subtract the 15 root 6. So 2 minus 15 is negative 13. And then you have your root 6, and negative 13 root 6 is your final answer. Okay, we're going to try one more that may be a little bit more difficult. So it's going to be 3 root 7 minus 5 root 14 plus 2 root 28. So for this one, the root 7 is the one that it is in its most simplest form, and I know that 14 and 28, they both have a factor of 7, so I'm going to try and rewrite those as root 7s. Let's see if that'll work. So 14, it doesn't really have any perfect squares in there, so this is just 7 times 2, and neither of those numbers are perfect squares, and the only other way to get 14 is 1 times 14. So I don't think I'm going to be able to simplify that one. But the 28 I can break up into the square root of 4 times the square root of 7. So that would be 2, square root of 4 is 2, and then the root 7. So this one would become a 4 root 7. And then I still have this 3 root 7, and then I don't think I can simplify this 5 root 14. So it looks like we're going to combine the 3 and the 4 to get 7 root 7. And then we have minus 5 root 14. So 5 root 14, like I said earlier, can't be simplified, so your final answer is 7 root 7 minus 5 root 14. So for these examples, we're going to be working on multiplying them. So we're going to simplify root 5 times root 3 minus root 75. So this is our first example. So we're just going to distribute right now because it's really our only option. So root 5 times root 3 is going to give me root 15. And then I have root 5 times root 75. That's going to give me root 375. So now I have to see if I can get these roots to match. So root 15 cannot be simplified because the only way to get 15 is 1 times 1 times 15 and 5 times 3. But the 375, we're going to see if we can simplify that into something that will end up with a root 15. So I know that 375 is divisible by 25. So we can do 375 divided by 25, and that will give me the factors. So that's going to be 25 times 15. And this works out because the square root of 25 is 5, and then the root 15 doesn't simplify. So we'll just bring this root 15, the root 15 down. So now I have a root 15 and a root 15. So the tricky part is we have to combine these together. So remember, when there's no number here in front, it's going to be a 1. So we're going to combine the coefficients, which is 1 minus 5 root 15, and that's going to give me negative 4 root 15 for my final answer. Let's do one more with multiplication, and let's do some binomials to review that FOIL. So our next example is going to be root 3 plus root 48 multiplied by root 20 minus root 5. So we're just going to FOIL this out. So we have root 3 times root 20, that's going to be root 60. And then root 3 times negative root 5 is negative root 15. Here's where it might get a little ugly. Root 48 times root 20 is root 960. And then our last ones would be root 48 times root 5. That would be minus root 240. So I don't know about you, but I am not feeling these large numbers at all. So I'm going to see if I can just simplify the radicals first and then see what happens. This is a great thing about math. If I don't like what I have, I'm going to try another way. So I'm going to take this root 3 plus root 48, and I'm going to see if I can simplify this. So this is going to be 8 times 6. I know that that's going to be 4 times 2, and then 2, 2, and this is 2 times 3. So I have a pair here and a pair here. So this is going to end up being 3 plus, and then we add 2 2's, so that's going to be 4 root 3. That seems like it's a lot easier. And then I'm going to take this one, this root 20 minus root 5. I know that 20 is going to be root 4 times root 5. So the square root of 4 is 2. So that's going to be 2 root 5 minus root 5. So that's actually a lot easier. So now I have 2 root 5 minus root 5. So in this case, trying to simplify the binomials first made my numbers a lot smaller and made this way easier to work with. So if we go back to our first binomial, we had a root 3 and a root 3. So we're just going to combine those together. Remember, when there's no coefficient, there is a 1 right there. So we have 1 plus 4, so that's going to be 5 root 3. And then we have a 2 root 5 minus a 1 root 5. Again, there's that missing 1. So 2 root 5 minus 1 root 5 is just going to be 1 root 5, or just root 5. And now we're going to multiply these two together. So now we're just going to do root 3 times root 5. That's root 15. And then there's nothing to multiply the 5 by, so your final answer is 5 root 15. So just again, if you are trying to FOIL out two binomials that contain radicals and your numbers get way too big, like they did up here, these were way too big and I did not want to deal with those at all, try simplifying the radicals first. So that's what we did here. We simplified the original radical on both of these binomials and it just ended up being so much easier. So keep that in mind as you work problems where you're multiplying binomials that contain radicals.